I started with Chakan as a greenfield plant. So we had laid out a vision. Our objective was to build 1,000 vehicles a day in the long term, not right now. That was one of the things. And also to be the factory of the future. So if you come to Chakan, you'll see everywhere the factory of the future. So we had to come up with a strategy to incorporate all the advances, changes, etc., coming in from all directions in the industry, as well as from the product engineering side. So taking into consideration, especially on my responsibility has been mainly on the manufacturing execution systems, lean manufacturing, and also designing new assembly plants. So one of the key things for a beautiful, efficient manufacturing facility is that you want it to be clean, visual, an aesthetic experience, and with great command and control. So if the supervisor comes out on the shop floor, he can see everything happening with one visual look. So to enable this, and also to enable all the lean manufacturing systems, we had to come up with an IT strategy, a multi-layered IT strategy to encompass and to give these features to the production managers. So that was one of the beginning we started out. So it is a massive plant. I have about all kinds of automation and machinery. And for example, our network, we came up with the concept of a plant floor controls network. It's purely controls. In the old days, we used to work on hardwired controls. That means all the wiring was hard. Multiple runs of wires from miles of conveyor were brought in back to the controllers, and that's how controls were executed. Now with the advent of the network, so we came up with the plant floor control network. We laid out the standards. We openly followed standards. That was the key to the thing, starting with the Ethernet IP, Siemens Profinet. These were standards, and these are the elements which helped us bridge the whole plant. Now the whole plant is about 14 shops spread over 300 acres. So it's a massive site. And we didn't want to do hard wiring across conveyors, etc. So everything became network-centric. Parallelly, we envisioned a completely IP-centric building management system for Chakan. So that was the other aspect of the initial greenfield design, completely IP-centric with building management system, complete manufacturing system, as well as the office system, as well as digital manufacturing system. For those of you who know or who don't know, digital manufacturing encompasses all the product lifecycle management systems which are used for product engineering, basically CAD, CAM, CAE support we have to give to the plant floor, as well as now the new element is how do we download all the parts, the bill of materials, the drawings, etc. So that comes in another software system called Team Center Manufacturing. So we wanted to adopt that. These are all high bandwidth guzzlers versus controls which are low bandwidth, but they're very deterministic in nature. So coming to the theme of machine to machine, this has always been there for the last so many years, or ever since control started. So only difference here is we moved from hard wiring to a IP network. Then comes the question, how do you do this for a real-time controls where determinism and bandwidth are very critical? So that's when we designed the whole system with a QoS in mind. And for M2M, the QoS is much more stringent than an ordinary network plant. It comes in terms of latency, it comes in terms of bandwidth, and it comes in terms of the accuracy of the data packets moving. All these come into the M&M. Now again, if you see at the end of the day in Chakan, we have about 330 PLCs talking to each other and talking to MES system. We have 350 display panels which are live and talking on Ethernet, displaying the status of their conveyors, their machines, the shops, the WIP, etc. We have about 1,000 motors being controlled. That's 1,000 IP points. And now with this next generation, these IP points have an embedded web page. So you ping the web page from anywhere, you'll see the entire diagnostics and the state of that machine or motor. That's the capability we have built in. And we are in the next phase, when we expand double what we have today, we will be getting that capability. So that is the kind of innovation we are pursuing in Chakan. Then similarly, we have network scanners. We have to scan these cars for parts, for traceability, for genealogy. All this infrastructure has to be integrated, and that's how we managed to do with the plant floor controls network. This is the first time in India, this was first of its kind. On such a massive scale, we've deployed the plant floor control network exclusively using Cisco hardware, Cisco Rockwell hardware. So that was a big achievement and accomplishment in terms of the size and scale, to give us all the tools and all the to enable all the manufacturing systems to not only communicate but also help in the production, because our volumes are very high. At any one time, I have about 1,000 vehicles you can see, and it's all done on the network, and it's all machine-to-machine talking. This MES is collecting the data, it's ordering, and you go and click on a screen, you'll see what model, make, color, type of vehicle, all that is available at your fingertips. And also later on, we'll enable your smartphones. So that is the scope and nature we started out with. Now, again, coming back to machine, there are a lot of standards, and we stuck to standards. And we followed the standards and implemented the standards so that there's no protocol issues, no loss of messages. And we also implemented safety over the network. Another first. Safety means if a vehicle is being lifted up or down, and if there's an unsafe situation or somebody walks into a light curtain in front of that, it immediately stops. That light curtain is communicating to my PLC via the network to stop the motion. And that's done and accomplished in milliseconds. So this is one of the key enablers for safety, and that's also being incorporated into the plant floor control network. So that is all machine-to-machine talking. Now, machine-to-machine, this is all on the industrial floor I'm going to talk about, because that's the theme of the whole thing. And now comes the smartphones. Everybody wants everything on the smartphones, especially the logistics part. See, the logistics plays a part. They bring parts into the assembly plant. And those parts get scheduled to a particular station where they are consumed by the manufacturing process. If they don't get there in time, you're shutting the process down. And if I stop the process, I'm losing production at the rate of, in Chakan, it's every 3 minutes. If I stop, I lose a vehicle. So that's a loss. So in my old job, it was every minute if I stop, I lost a job. So this is a little slower in nature. But that is the impact. Then you have so many lines and so many systems going on. So it becomes very critical to maintain this thing. So the machines which are on the floor are programmed and are communicating with other machines to get the parts, to get the conveyors in place. Similarly, one of the biggest challenges was in one of the vehicle lines, we have an electrified monorail which goes around. It's independent carriers. They can think. It's all with machine control. But how do you communicate? The traditional way was to use the bus bar. Feeding power through a bus bar to the electrified monorail. So how do we communicate? Because it was very unreliable. So we switched over to wireless. So I have 33 carriers producing 30 Maximos an hour, communicating between themselves and communicating to the central controller. So this is a type of machine-to-machine which is happening on the floor. Then comes, how do I identify which vehicle is there on which carrier? That's where RFID comes in. So we'll be talking about RFID a little later also. So by the use of RFID, or even a leaner way is just use a barcode and read it. And the barcode sits on the network. So you got the data, you know where the vehicle is, so you're able to do that. And that vehicle and that data is transmitted to MES. I hope everybody knows what MES is. MES stands for Manufacturing Execution System. What MES does is it aggregates all the different lean manufacturing systems and then sets up a production system and also interfaces to the ERP. So as I consume parts on the vehicle, I'm also able to update my ERP live in real time. I've consumed these parts, you can pay the supplier. That is the goal, ultimate goal. So, so that is all machine-to-machine talking. And going from there, we basically come down to the concept. Everything in the manufacturing floor want to be identified, either through an RFID or through a barcode. And then I need to read it somewhere and get it on the system, through the MES system. So that is my temporary cloud. It's not really a cloud. It's just an aggregation of SCADA screens. But yeah, I would like on a 1,000-acre plant site, I would like to have my private cloud, and all these devices become internet on the internet. Similarly, when I'm receiving parts, just in sequence, just in time, I have suppliers outside the plant who are looking at my broadcast. I'm broadcasting, this is my production, this vehicle is in body shop, next one is in paint shop. I'll be reaching this destination approximately this time in general assembly. So what the supplier does, he back calculates the lead time, and exactly at that time, he's shipping the parts based on his transit time. That's called just in sequence. So right now, we're in Chakan. We have a supplier supplying full cockpits. A cockpit has a steering column, the entire instrument dash, radio, glove box, airbags, as well as the steering column bolt, the mechanism in the steering column. And these items are also traceable. That means they require traceability by the government. That when was it made, what is the serial number, what is the manufacturer of the airbag lot. So what the GIST supplier does, he gets that data and puts it on a barcode. So when it comes to the point of marriage, we read the barcode, we know what vehicle we are building, we are verifying that yes, it's the correct vehicle, and then data gets archived. So this is the kind of track and trace requirement which is required in manufacturing. And to enable this, machine-to-machine is one way of enabling and empowering. The second way is we also embed RFID. So what happens is when we first build the body shops, where all bodies are built, they all go through a paint shop. Generally, dedicated body shops have a dedicated paint shop, and they go to the general assembly. In Chakan, we have one paint shop handling all the bodies, car bodies and vehicle bodies. So they all go into this melting pot and they come out. So right now we have to manage the flow. So what happens when the bodies get built, they get put on a carrier with an RFID. So I know where that RFID and what body is on that RFID, and that the conveyor system delivers to paint. So I have a complete live SCADA screen showing this is the vehicles, this is how it's going. Now, how does this help? In two ways. Now, paint shop typically can paint all reds, all whites. They do batch painting, they do style painting, and they also need to set up their robots to get the correct robot program when a certain model comes in. So what this RFID does is it gives us the ID. Then I have a sequencing software, which will say, based on constraint theory, I put constraints that this is how you're going to feed to the paint shop. Is by batch, by time, the color, the style, all that can be set up, and paint shop can receive it in that sequence. And that is carried out storage and retrieval systems. We have in the conveyor system. So that capability is what RFID enables on the plant floor. So one is it visualizes the entire WIP. Second is it lets you select and make your manufacturing process very efficient based on the capability and constraints of the next downstream process. So that's one of the big enablement, and we are doing right now with RFID. So that's the entire tracking is done of vehicles, manufactured vehicles on RFID in Chakan. But it's not as pervasive as I would like. I would like to extend it back right from the first part till the last part. But what happens is when you go through paint shop, it's a very discontinuous process. Sometimes the tags get lost, and the tags are not temperature. They have to go through ovens. So we cannot send them through. There are high temp RFID tags have come over, but it involves a switch. So there are tags of all kinds available, and based on, again, I don't know how much familiar with RFID. What RFID you have at a low frequency, you have at medium frequency, microwave frequency, all these frequencies are available. Now, like pallets, if I'm delivering engines in pallets, I can track them within the plant because I have an engine shop which builds engines. And there's a pallet number and there's an engine number. And that is meant for a vehicle X with these variants. So I can get it shipped, tracked and shipped to that point in that sequence. So that is the capability of RFID. So it's a very, and we are not only RFID, but prior to RFID, you could also do jugaad with barcodes. Do with barcodes first, works, then put RFID, because these tags tend to disappear magically, then it becomes a people problem. So that type of enablement and visualization is very key to manufacturing, because that gives the manager a broadcast where his bottlenecks are. So that is, that again all fits into machine. It's all going into a PLC. So we try to standardize everything around the standards, which is Ethernet IP, which is a deterministic protocol, or in the Siemens, we use two kinds of PLCs, Siemens and Rockwell. Siemens uses TTP, time triggered protocol, which is the Profinet, and we process that. Similarly, we have on the Rockwell side. So that's the ability of RFID tagging. Now, can I have all the parts tagged? Yes, you can, but you have to look at the price point. So it's very key on the floor to tag and track. Now we have the MES system. What MES system is depending on this vehicle tracking. So how that works is we know which vehicle is in which location, and we know in MES which processes are being executed in which stations. So when, suppose I get a vehicle into a glass, glazing area, I know and there we get multiple models. So I know it's a two-door, so it gets a certain type of glass. That all comes through the bill of material to MES from the ERP. So we know at this process, when we are tracking, this vehicle comes, so I download a bit to the robot saying, do a two-door. So the bit says two-door, robot executes a two-door software program, and the vehicle indexes out. So that is the other capability in track and trace you're going to get. And we're doing that currently. It's done, I've done this in GM in the past. So I'm able to download, we call the whole vehicle data, option data delivery, and it's all based on the variant. A variant going to Angola has these tires, has these the moldings, has these types of seats. They're all identified on the floor by MES, and MES drives the local PLCs, saying that when this comes, you execute this program. Another good example is a brake fill machine. Depending on the size of the brake or size of the vehicle, the volume of fluid, brake fluid going can change. So we vac and fill in. So these are the types of machine-to-machine dialogue, which is always going in real time, and it's based on positive ID of the vehicle, or even we also manufacture engines, about 1,000 engines a day. So even engines we track. Same processes when you're torquing the engines, when you're testing the engines for leaks. Similarly, we track them through MES as well as through either barcode ID or RFID physically, and translate that into process knowledge. So this is all the practical real-life applications. Next comes quality. Everybody wants quality. How do I get quality? How does tracking help quality? So if you look at quality, in M&M, it's a pretty elaborate system. We start right from the time body starts. So we have various quality inspection stations. We have provided them touch screens. These are our factory talk software clients, MES clients. And then the visual screens come with the drawings or the door panels or wherever. And depending on the area, the defects are codified. So he picks the standard defects. And he just touches them, and they collect all the defects. And that is in real time available to the whole world via reports. So you can see the reports, and you can be proactive. So what happens, suppose in paint, I get vehicle is entering paint, and he notices all dings and scrub marks, etc. So he enters that, and then what happens is we do a feedback messaging to the station where these faults are originating. Hey, you've got an alarm. This is what's happening. Check your tooling. Check your process. That's the other advantage of tracking everything on the plant floor. And it gets elaborate. Similarly, you track it all the way to the shipping, and all the defects which shouldn't have gone in the first place. If you follow lean, you don't forward a defective part, but sometimes things happen. It goes in, and then they have to feedback. So that's like the insurance policy. It captures. But you follow lean properly, you should be fixing the defect. Now, part of that also we do is we give the and-on, which is again, the operator pulls an and-on code. The machine tells him, hey, this guy needs help at this station. So that's the visualization. There again, we know which station the pull code came from, and we display the message. These are all machine-to-machine communications, and then to the visual. Now we are having the visual displays, and the reason we have the visual displays is for the supervisor to see who needs help. We can send him an SMS, but then he could not see it or he could ignore. But the process is to get him on the ground to repair, not sit in an office. So that is some of the importance of track and trace. Now this thing can happen in process industry as well as other industries too, like medical. What are the recipes getting downloaded? You can monitor, you can track, they can label them with RFID or barcodes and track and do the certification in a medicine type of environment. We have the similar thing in our paint processes. We have ovens which are doing PID loops. We have paints, we have robots doing for different programs. These are all part of the tracking concept. Now, wherever possible, we try to do with RFID where it's elegant. Otherwise, we switch to standard barcode. We put the barcode label and the guy reads.
So I have a simple question. So, consider yourself 10 years from now, right, in a futuristic factory. So we all know M2M has got a major play today, and by that time, I would think 95% of the things would be automated. So what is your opinion where there is a line between how much of automation in M2M versus do you really need a human element there to monitor or control a few things? I just want to get your opinion, you being in the the automation area.
The thing is, in automotive manufacturing, there will be people always. It's not going to be 100% automated because of the interior. It's very difficult to automate. So there will always be people. But whatever straightforward jobs or heavy lifting jobs, like lifting the tire and putting, you need to automate that part. That is a human thing. And that's where my past comes, collaborative robots. We have tools which can, you use haptics in the handle. Actually, that was nothing but our CAD-CAM big ball. We took that and converted it into a handle, and you put pressure less than 1 pound in any direction, translate that to motion in XYZ. So that's what a collaborative robot does. It's all in the works. And part of that work has now come into your arms, and the exoskeletal stuff too. That's one of the things when we were doing research at GM, the exoskeletal to help people. And actually the professor developed it and the US Army grabbed it. And GM went bankrupt. Otherwise, I would have put a guy lifting seats. So you won't have the cumulative trauma. If you do 60 times a day lifting seats, you're going to be in trouble, no matter what anybody says. So that is why.
Okay, thanks.
I wanted to understand your opinion in terms of OE when it comes to
Okay.
M2M.
As we are monitoring and the machines are talking to each other, we're also monitoring the performance of the machines. So there are always metrics available in the machine, which we can monitor in real time and determine their efficiency as well as their performance. Now in the industry jargon, they call it OLE, overall line efficiency, and OEE, overall equipment efficiency. It should always be 100, theoretically. So that is monitored and we can track it. And a lot of this data, if you analyze, you can get it back into my digital manufacturing, discrete event simulation, do a simulation and find out the bottlenecks. Which machine, suppose I have a machining line, there'll always be some bottleneck or some guy goofing off. So you can actually in real time get that data, feed it, and it'll tell you which machine is your bottleneck and how you need to rearrange the process. You can do what if in the digital manufacturing scenario and do a simulation whether the machine can do it differently, or you can reduce the cycle time of certain operations, or you increase the buffer size or decrease the buffer size. These what ifs will give you a solution, and that capability is also available now.
Like wherever we are using the RFID and barcode, maybe especially I'm talking about the RFID, maybe we can even use the NFC, that is a near field communication, where these devices can pair with the Bluetooth or even the Wi-Fi devices. This NFC is still upcoming technology and it's going to have a good future. Maybe we can plan to use that. What is your thought on this?
There's a mobility, machine to machine, mobile device management. So that's where these mobile devices come in. You take them in a machine and they establish communication, and like audits, like we have torque audits, where the guy is torquing and sees I've met the torque compliance or not for legal reasons. So I can just take this to that tool and it'll tell him this is done. So that's portable tools. He can take it with him and do. So how do you manage a mobile device on the factory floor is a challenge.
It's need not to be a mobile device always, and it can be even any NFC reader which can make this, and which can be paired with Bluetooth or Wi-Fi devices as well. So I think that can help us when you think in terms of wireless.
Yeah, see, the one thing we do with wireless right now, one is we are doing machine control and they're communicating. The other thing we wanted to get into, when you get into pervasive wireless use, then all the sensors of the machines will also have a wireless interface. They'll automatically, based on the programming you do, they can communicate. And yeah, the readers, like RFID is again read-write. You can put the RFID read-write, it'll read the tag or whoever's going across, and then send the data back. But the thing is, how do you set up this whole cloud in the factory floor and manage in real time is the next challenge.
Hi sir, this is Ganesh. So do you foresee, because I could see a tremendous amount of operational excellence using machine to machine, so take it to the next level on real-time analytics capability, where after operations and then tactical and strategy, having these three things in a snapshot, is there a real requirement on the analytics space?
See, we want analytics, like we're trying to do dashboards showing actual production. So that part of analytics is part of this package. We're just getting started because we're having issues with the reporting database and how fast we can get it out.
That's where we are, our team is in, so we can definitely have an offline talk to give a solution.
Definitely. We can take care. So we're having, see, everything, the key is any database. If you don't design right, don't set up the relationships, then your queries become longer and longer and longer. That is fundamental to the whole, but we all forget that and we'll say, put a front end and it'll do. But the first query you run, you're jammed. So, but yes, definitely analytics play a part, and I can see my production right now, that capability is there. The question that now I'm giving all that. Now the question is I want managers to use. That's the thing. Unless how I use and how do I do is total decision-making support. This gives you all the decision-making support, then I need to make the right decisions. You know, when to start the shift, once to start, because there are 3,000 people on the line whom you have to send home if some part of process is messed up. So this capability is there. I wish I had it 15 years, 20 years back, then it would be nice. Okay, thank you very much.
Thank you.